Hello guys, welcome to Universe Science TT once again. Please don't forget to like and subscribe to our channel. Our today's topic of discussion is based on some notation of sets. So here we go. Number one is equivalent set. When we say equivalent set, we are referring to the types of set that have the same number of elements, but it's not necessary for the element to be the same, just only the number of the element. For example, if A has element, for example, A, comma, B, comma, C, and B has element 1, comma 2, comma 3. So definitely A is equivalent to B because all matters here is the numbers of the element, not the time of the element present in that particular set. So this type of set is called equivalent set. So number two, we are moving to another, that is what? Equal set. When we say equal set, both the number of the set and the type of the set in the two sets must be the same. For example, number two, in set A, for example, if you have 1, comma 2, comma 3, also in set B, it must be 2, comma 1, comma 3. The reason why I change the arrangement of the element is because to show you that the arrangement doesn't matter, but all matters is what? The type of the element and the number of the element from the two sets. Just the type of the element must be equal to the order as it is in the order set, as well as the number of the elements. So as you can see here, we have 1, we have 2, we have 3. Also here we have 1, we have 2, we have 3. So therefore A is equal to B. So now we are moving to number 4, that is less than. If we say less than, we are referring to numbers that below that particular number. For example, now, number 3. Now, for example, if we say number less than 5, or let's say if x is less than 5, then x can be 1, comma, can be 2, can be 3, and can be 4. So these are the numbers that are below 5. So that's what we refer by less than. So now we are moving to the number 4, that is what? Greater than. If we say greater than, we simply mean the number greater than that particular number. For example, if x is greater than, let's say 5, then x can be 6, can be 7, can be 8 into infinity. So any number above 5, x can carry that number. That's what we refer by what? That's what we refer to greater than. So now we are moving to the next notation, that is what? Infinity. Everyone knows infinity. If you say infinity, we are simply refer to what? Uncountable numbers. For example, now we can refer infinity as the numbers of stars in the sky, or number of some rice in the bag of rice, and so on and so on. So if you say uncountable, we are simply referring to infinity. For example, now the amount of, let's say, stars in the sky. Definitely this is uncountable, so that's what we refer to as infinity set, and this is the notation of infinity set. So now we are moving to the next number, that is what? For all. That is for all. Number 6, for all. For all is a frequent notation that used in a set. For all can be used in a generalizing something. For example, if I say if set A has, let's say, 1, 2, 3, and set B has 4, 5. Then for all set A and B, let's say this is you were asked to find the union of A union B. So for all A and B can be given as 1, 2, 3, 4, 5. This is the frequent notation that are used in the set. So now we are moving to the next one, that is what? That is empty set. If we say empty set, we are simply referring to the type of set that has no value on it. For example, now, number 7, empty set. This has notation. That's how it is. Notation it is. So now, if we say empty set, we are simply referring to the set that has no element. For example, now, if you are given a set, for example, x, such that x belongs to real number square plus 1 is equal to 0. In this world, there's no real number square plus 1 that will give you 0. There is not. Because if we say real number, we are referring to a type of number from 1 to infinity. There's no value, such value that will, if you square it in a real number and you add 1 on it, it will give you 0. That's definitely, there is no that number. So this set can be referred as what? As empty set. There's also another name of empty set. It's also called what? Null set. Empty set is also called null set. So if we say empty set, we are simply referring to the type of set that has in it. So now we are moving to the next. That is what? We are moving to an implies that. Number 8 implies that. If you say implies that, we are simply referring to just like therefore. It's a common notation that is used in what? That you usually use in sets. For example, now if you say, if set A has 1 comma 2 and union set B, which has what? 3 comma 4. So if you are asked to find the union of A and B, this implies that union A union B will be 1 comma 2 comma 3 comma 4. So that is the function of implies that. It's just functioning just like therefore in what? In set. So now we're moving to the next, that is what? We are moving to curly bracket. You know, in set we are not using the usual bracket because it has its own different bracket, which is called what? Which is called curly bracket. So it has represented like that. So that's why we call by curly bracket. We are not using the normal bracket as we know in the sets, but we are using what? We are using the curly bracket. So now we are moving to the next one. That is what? Less than or equal to. Less than or equal to is different from less than. If we say less than, we are simply referring to number below that particular number. But if we say less than or equal to, we are referring to what? Number 9. We are referring to number, that particular number and the numbers below it. For example, let's say if x is less than or equal to 5, then x can be 5, can be 4, can be 3, can be 2, and can be 1 below. So that's why we refer to what? Less than or equal to. So now we are moving to number 10. That is also what? Greater than or equal to. If you say greater than or equal to, just like less than or equal to. In greater than or equal to, let's say x is greater than or equal to 5. That's also what? 5 is included. This will be, we will start from what? From 5, then 6, then 7 to infinity. So that's why we refer to less than or greater than, less than or equal to and greater than or equal to. So now we are moving to the next one, that is two sets. So next we are moving to what? We are moving to the union of two sets. If you say the union of two sets, we are simply referring to type of set, or if you say union of two sets, we are simply referring to the addition or sum of that two particulars or of that two sets or more. For example, now, listen, that's number 13, right? If A has element, let's say 1 comma 2 and union B, and B has element 3 comma 4. So this implies that A union B will be written as 1 comma 2 comma 3 comma 4. So that's what we refer to what? A union B. So if you see union, we are simply referring to what? Addition. So this proper set and superset, they are another type of a set. They have more explanation. I can even say they are topic on their own. So you can search for them on this our channel, because we explain more about proper set, superset, and so on and so forth. So you can search for these two on our channel. All what matters here is the notation. Just note the notation of superset and proper set. Now we are moving to the next one. That is what? There exists. If you say there exists, we are simply referring to the numbers that exist. Here is the sign of the what? There exists. We are simply referring to the number that exists. For example, now I can say there exists a value real number square plus 1 is equals to what? Is equals to 5. Exactly, there's a real number square plus 1 is equals to 5. Like what? 2. 2 is a real number, and 2 square is equals to what? 4. 4 plus 1 is equals to 5. So this we can say there exists a real value is equals to a real value r square plus 1 is equals to 5. And if you say we are moving to the next one, that is what? There does not exist. If you say there does not exist, we are simply referring to the value that does not exist. For example, as I gave example in this empty set, we say a real number square plus 1 is equals to 0. There's no such value in mathematics. There's no value that if you square it, or real value square plus 1 that will give you 0. You know, there's different types of numbers. And we explained this in one of our tutorial video. You can search for type of numbers in our channel. So this can definitely be referred to as what? There does not exist. Because what? There's no real value square plus 1 that will give you 0. So now we are moving to the next one, that is what? Belongs to and does not belongs to. If you say belongs to, this is as normal English. We are simply referring to the element that belongs to a particular set. And if you say does not belongs to, we are referring to element that does not belong to that particular set. For example now, if I say in set A we have 1, 2, 3, then we can definitely say, for example, 4 does not belong to set what? Set A. But what? 3 belongs to set A. Sorry, 3 belongs to set A. So this is sign of belongs to and does not belong to. If you say belongs to, we are simply referring to the element belongs to that particular set. And if you say does not belong to, we are referring to the element that does not belong to that particular set. So now we are done with belongs to and does not belongs to. This is does not belongs to, and this one is the belongs to sign. So now we're moving to the next one. That is what? We're moving to equal. We're moving to it's not equal to and it's not equivalent. It's not equal to and it's not equivalent are just opposite of equal to and equivalent. If you say something is not equal to, we are simply referring as the opposite of equal to. For example, if set A has 1, 2 and set B has 3, 4. It is obvious that A is not equals to what? It's not equals to B. So as you say, as we said before, if two set has to be equal, the element in the set and the number of the element has to be the same. So we can see here the number of the element are the same, but what? The type of the element in that two set is not the same. So this two set is definitely what? It's not equal to. So now if we say is not equivalent. If you say something is not equivalent, we're simply referring to the number of the element in that two sets are not equal. For example, now in set A we have A, B, C, and in set B we have 1, 2. You see the type of the element are not the same as well as the number of the element. Had it been the number of the element are the same, we can refer this as what? Equivalent set. But also the number of the element in that two sets is not the same. So this can be referred to as what? Not equivalent, sorry. That is, it's not equivalent set. So now we're moving to the next one, that is what? Subset and not subset. If we say subset, we are simply referring to the subset of that a particular set. For example, now, if A has element 1, 2, and B has element 1, 2, 3, it is definitely that A is a subset of B because the element we have in set A are element of in set B. So for a set to be a subset of the other element, it must contain the element that is present in the other element. You see here we have 1, 2. Here also we have 1, we have 2, we have 3. So if you see this set A can fit into set B. So we can say A is a subset of set B. So that's what we refer to by subset. And if you say not subset, that is element in set A are not the element of set B. For example, if A has element 1, 2 and B has element 1, 3. So as we can see here, A is not subset of B because there's no element 2 in set B. So this is not subset because for a set to be the subset of the other set, the first set must contain all the elements in the other set. So you see here 1 and 2 are all the elements of set B, but here there's 1. We also have 1 here, 2, but there's not 2 here. So it is definitely that A is not subset of B. Here A is subset of B. So now we're moving to the next one, and this is the last one. That is what? That is factorial. If you say factorial, we are simply referring to the multiple of that number plus from the number after it to 1. For example, now 5 factorial can be written as what? 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So that's why we made by what? By factorial. So now let's give another example also. For example, if I say 4 factorial, then we are starting from the number behind that 4. You see, for example, 4 multiplied by 3 multiplied by 2 multiplied by 1. That's why we made by what? 4 factorial. So this is how we are multiplying the value of factorials. So guys, these are some notation you need to know before getting into elementary offset. I hope you enjoyed this video, and please don't forget to subscribe to our channel and hit the bell button so that you'll be notified whenever a new video is released. Thank you.